Hello, good morning, friends. How are you? I hope all of you are safe and sound at your home. So, today we are going to see here the new topic from our CBOP-3 Analysis of Food Analytical Chemistry paper from the MSc Part 2nd. Okay, our today's topic is moisture and solid analysis. Moisture and solid analysis. Okay, so the first point is introduction. We know that in the analysis of food, the moisture content is very important because this moisture is playing a vital role in determination of different food additives and food nutrients. Okay, so that's why while keeping this food quality superior, we have to analyze this moisture and total solid very carefully. So okay, so what is mean by actually moisture? So moisture is nothing but the wet part or wet matter of that food is known as, or which is related to the water content of that food material or food product, it is known as moisture. And the remaining part, after removal of that moisture, the remaining part of that food products is called as total solids. Okay, so what is meant by total solids? When we are removing the total moisture or the wet part of the food product, the remaining part we call it as a total solids. Now, what is the actual importance of this moisture and total solid analysis? We are doing analysis of this moisture and solid part of the food product. Now, what is the importance? This is actually a very fundamental or very important part of any analysis, because this moisture analysis we require for the nutrient part of that food material. Okay, means what? If we purchase any type of food material from the market, then it has a label, and that on that label the total analysis, the major analytical analysis part is printed on that label. Okay, which includes the carbohydrates, proteins, amino acids or calories, how much amount of energy we are getting from by consumption of particular amount of that solid material or that food material. That all information is printed on that label. Okay, so it is also the printed material of that label also has some moisture and total solid analysis. Okay, for example, if we have the milk etc. or the milk products, so milk has two major part, that is what is the fat and what is the solid non-fat. Okay, so it has two parts, that is weight analysis, and the second one is solid analysis. So in solid analysis, milk has two types of solids, that is fats and solid non-fats. So okay, all this information is given in the that analysis. Okay, then this moisture and total solid analysis also having importance in some jams, jellies, their water content. Okay, then sugar syrup, etc. Okay, then the water which is present in these food products can be have different types. There are mainly three types of water present in the food products, and these are mainly free water, second one is adsorbed water, and third one is water of hydration. Okay, so first one is free water. So what is free water? Free water is nothing but it has retaining its own properties. The free water is retaining its own properties in the food products. Okay, so we cannot distinguish between the free water which is present in the any form or in any let us say glassware, and the free water which is present in the food product. Okay, for example, milk. So milk, we know that about 80 to 90% of that milk is made up of water. Okay, so this water which is present in milk and the usual water that we are using, drinking for drinking purpose and using purpose or etc. We cannot distinguish. So it is retaining its own physical properties, and it is the easily determined part, or this free water can be easily determined from the analysis of the food products. Then the second one is adsorbed water. Second type of water present in the food products is called as adsorbed water. So adsorbed water means this type of water molecules are get adsorbed, or they can be occluded on the surface of that food material or on the surface of protoplasm or protein part in the food products. Then the third one is water of hydration. So these water of hydration molecules are generally chemically bounded by formation of hydrogen bonding etc. in the food products. Okay, for example, in chemical compounds such as sodium sulfate, okay, or calcium sulfate, we write that formula calcium sulfate as CaSO4 CaSO4 not 5H2O. So these water of hydration, 5 water of hydration molecules are get bonded to these calcium sulfate molecules. In similar way, these water of hydration molecules are present in the food products. Okay, so these are the three different forms of water which are present in the different food materials. Then the next point is moisture and total solid analysis. Okay, so this is actually the main core of this topic, that is moisture and total solid analysis. How to do this moisture and total solid analysis? Okay, so there are different methods for this analysis. First one is oven drying methods. Oven drying, we know that we have to determine the moisture content of that any food material, and to determine this moisture content we have to first of all do the drying. We have to do the drying of that food material. Okay, so as we know that drying is done in presence of temperature, that is heat energy. With the help of heat energy we can dry the food material. Okay, in old days or in previous days, the sunlight is the main or the usual source of heat energy which is required for the drying purposes. For example, the food grains which are obtained from the field crops, they are dried before they are packaging into the what we call the packing material, okay, etc. So oven drying method is one of the simplest form of this drying for moisture analysis. Okay, in this case the sample is heated in a at proper conditions of temperature. Okay, and during this heating the water is lost from that food molecules or food products, and the lossing weight of that food material or food product is used to calculate for the calculation of moisture content present in that food product. Okay, we know that the moisture, that is nothing but the water present in the food material, has the water has boiling point of 100 degrees Celsius. But this 100 degrees Celsius boiling point of water is related to the free water, let us say. So when we boil free water at sea level, then that at sea level water boils at 100 degrees Celsius temperature. But we know that elevation in boiling point, this concept. Okay, so when we add any non-volatile solute in the solvent, then there is increase in the boiling point of that solvent. So that's in the similar way, due to the addition of these different foodstuffs into that water present in that food material, the boiling point is get elevated. Okay, and due to this, when we are increasing the temperature for the purpose of drying of that food material, decomposition of other food constituents may be possible. So decomposition of food materials is possible, and so that's why this should be considered that the temperature controlling must be achieved for the oven drying method. Okay, because once the food materials, the food constituents present in the food samples, if it is get decomposed, then it is of no use. That is we are measuring the moisture which is present in the food materials is not getting accurate results. Okay, for example, we have glucose, that is C6H12O6. Okay, so this glucose, when it is heated strongly, this glucose material is also get denatured, it is also get decomposed at 100 degrees Celsius. So at the same boiling point of this of water, 100 degrees Celsius, this glucose material is get decomposed, and so that's why we get decomposed into 6 carbon plus 6H2. 6 carbon plus 6H2 means if we are measuring or if we are calculating the moisture content present in the glucose material, okay, so our most first attempt is the drying of that substance, okay, or drying of that food material. Now our food material, if it is having carbohydrate, that is the simplest carbohydrate is the glucose, and this glucose is get decomposed at 100 degrees Celsius, which is nothing but the boiling point of water. So that's why at this temperature also the glucose is get decomposed into 6 carbon and 6 water molecules. So water molecules are get generated in the decomposition. Okay, so that's why these water molecules may also disturbs our analysis. Okay, in what respect? We are analyzing the moisture present in the foodstuff or food material, but in this case, in the process of drying, in the process of calculating the moisture content, the water molecules are get generated in this process. That's why it may get interfere in the analysis. Okay, so that's why this should be taken into consideration. Then the next one is types of pans used for the oven drying. Types of pans, different types of pans are generally used for this analysis of moisture contained by oven drying methods. Pans means the surfaces having the place for the spreading of that or spattering or spreading of that food materials or food products over the flat surface, over the circular surface. Okay, so we can spray that our food materials on the surface of which we call it as a pans. Okay, so these pans are of different sizes and different diameters. Pans can be used for this oven drying method. Okay, this is dependent on generally on the type of food that we are analyzing, then the amount of food sample that we are using for the analysis. Okay, then after drying, if we when we are obtaining the data, that is how much amount of water is get evaporated from that food sample. Okay, then after evaporation there should be decrease in the loss in the weight of that sample is done. Okay, and from that loss in weight data we are calculating the moisture content present in the sample. Okay, for example, there are three calculations or three formulas are there for the calculation of this moisture and total solid analysis. The first one is percent moisture weight per weight. Percent moisture is calculated on the basis of weight per weight basis. It is nothing but weight of water, weight of H2O in sample divided by weight of weight sample. Weight of weight sample. This weight is different and this weight is different. Okay, this weight is amount or mass, we can say this weight is related to moisture, means gila. In Hindi we call it as a gila, or in Marathi we call it as a ola, ulcer. Okay, so weight of water in sample divided by weight of weight sample into 100. So this is the simple formula for the calculation of moisture on weight per weight basis. Then the second one is second formula. The substitute formula for this is percent moisture on weight per weight basis, and it is nothing but weight of weight sample minus weight of dry sample divided by weight of weight sample into 100. So this is nothing but the difference between the weight of sample, food sample before and after drying. So the weight of weight sample, this is the weight of food sample before drying, this is after drying. So this difference divided by weight of weight sample into 100. This can be used for the calculation of moisture analysis. Then the remaining matter we call it as a dry matter, and that dry matter is nothing but total solids. So the percent total solids on weight per weight basis can be calculated by weight of dry sample divided by weight of wet sample into 100. Weight of dry sample divided by weight of wet sample into 100. So this formula can be used for the calculation of moisture and total solid analysis. Okay. Then this is the first main type of moisture analysis, moisture and total solid analysis. Okay. That is oven drying methods, simple oven drying methods. Okay. Then the second most important is a forced draft oven. Second type is called as forced draft oven. So what is force? So this word is important. Forcefully means sample is rapidly weighed. Sample is rapidly weighed into a pre-dried moisture pan. Into a pre-dried moisture pan. So pre-dried moisture pans means the moisture pans on the surface of which we are determining the moisture content of that food sample. That moisture pan is pre-dried. Okay, with the help of steam at 100 degrees Celsius. A steam with the help of steam, that moisture pan is preheated or it is pre-dried, and on that pre-dried moisture pan sample is rapidly weighed. Okay, so that's why this type of oven is called as forced draft oven. Okay, and the different temperature conditions are used for this forced draft oven, and these temperature conditions are depending on the type of food material, nature of food, then boiling point of different boiling and melting point of different constituents present in that food sample. Then the third one is vacuum oven drying. Okay, now it is well known to us what is it by vacuum. Vacuum is nothing but the process at which we are doing at a reduced pressure. Okay, so drying under reduced pressure. So pressure is reduced as compared to the atmospheric pressure, which is nothing but 1 atmosphere. So pressure is reduced at below the atmospheric pressure, and the drying process or drying purpose is achieved. Okay, so drying under reduced pressure without decomposition of food material within short period of time, generally 3 to 4 hours, because these methods may take 1 hour, 2 hour up to 24 hours. These methods may longer time. Okay, but vacuum oven is one of the new technique developed for the drying purpose, and in this method we are drying or evaporating that water content of that food sample at reduced pressure. Means the general normal boiling point of water is 100 degrees Celsius. Okay, and this is nothing but at atmospheric pressure, because the definition of boiling point is nothing but the temperature at which the liquid boils and at which the vapor pressure of that liquid becomes equal to the atmospheric pressure. So, okay, so at this temperature, the vapor pressure of that water and the atmospheric pressure is same, that is 1 atmosphere. But when we are decreasing the atmospheric pressure below 1 atmosphere, the water is get boiled at low temperature. Okay, generally at 70 degrees Celsius. Generally at 60 to 70 degrees Celsius, this water is get boiled. Okay, so no doubt the pressure is adjusted accordingly as per the calculations. So this is the most important. What is the benefit of this? When we are reducing the pressure, accordingly the boiling point of that water in the food sample is also getting decreased, and that's why due to this low temperature, the food constituents which are present in that food sample, they are remaining as it is. There will be no any chance of decomposition of that food material. So that's why all these food qualities, all that food nutrients are present as it is. There will be no any decomposition, just like that we are seeing in the case of oven drying methods. Okay, so no doubt temperature depends on the product, which type of food product that we are analyzing in this case. Okay, for example, the liquid samples. For example, see sugar syrup, jam, jellies, cocoa products, that are nothing but liquid products. Okay, so liquid products contains mainly the water as the main constituent in these liquid products. So they can be adjusted. The pressure and temperature can be adjusted. Then consider the volatiles. Then different fats. For example, the different fats have the fats are generally having high boiling points, but the different components which are present in these food products, if they are having low boiling point, then this point should be taken into consideration, because when we are reducing the pressure, boiling point is also getting reduced, and so that's why they may get volatile. Okay, so that's why means we are focusing our attention to the water, but at the same time there should not be a loss of other volatile materials present in the food products. Then one observation is general observation is there. When we are using vacuum oven, then the endothermic process, means reducing pressure is endothermic, reducing boiling and reduce the pressure is an endothermic process. Okay, so that's why as it is endothermic, heat is get absorbed in the process. So that's why cooling is generally observed in this vacuum at the outer surface, external surface of this cooling oven system. Okay, and drying time. So drying time in this vacuum oven is a function of type of product, nature of the food material, then surface area available for the drying pan, then number of different components present in the food materials. Okay, all of these. Okay, so that's why this is drying time is depending on the all these different factors. So that's why this vacuum oven drying is generally a new technique, and it is utilized for the moisture and total solute analysis. Okay, so this is all about the today's lecture. This is the new topic for us, that is moisture and total solute analysis of the food material. What we have seen today, we have seen the introductory part. Then the second one is what is the importance of this moisture and total solute analysis. This is not important, not only important in the food analysis, but in case of any analysis, in case of pharmaceuticals, in case of paint industry, in case of sugar industry, any type of chemical industry is there, the moisture analysis and total solute analysis has its own importance. Okay, then we have also seen the forms of different water present in the food materials. These are free water, and some water and water of hydration. Then we have seen the three major methods for the analysis of moisture and solute, and these are oven drying methods. Second one is called as forced draft oven. Third one is called as vacuum oven. Okay, details of this we have also covered, and we have also seen the calculations, how to do calculations for the moisture and total solids for this food materials. Okay, so I think you got it properly. Okay, thanks for seeing this video. Have a nice day. Thank you very much.